This factory turns simple wheat dust into over 1 million noodle meals a day corns. How do they keep every single one exactly the same?
Watch closely, because every tiny movement you're seeing is controlled down to fractions of a millimeter.
From the outside, it looks like any other plant, but inside is a high-speed system built around one cheap, forgettable snack.
Flour comes in one side, sealed cups leave the other, and almost nothing is left to chance.
To understand how this works, we start where every noodle begins, with raw materials.
Because if the inputs aren't controlled, nothing downstream can ever be consistent. Truck after truck drops off wheat flour, the basic dust that will become your noodles.
Even this powder is standardized for protein, moisture, and particle size.
Vegetable oil follows a different path, heated and pumped, so it's ready exactly when the dough needs it.
Seasoning blends are pre-measured, so later robots can drop almost identical grams into each cup.
Ingredients meet in a mixer strong enough to knead hundreds of kilos at a time.
Texture is everything. Too soft and it tears. Too stiff and it never forms into that familiar brick. Operators still use feel and experience to confirm what sensors can't fully capture. But
The dough rests just long enough to relax the gluten so it can be rolled without tearing.
This is the beginning of the endless noodle sheet that will feed entire cities.
Thickness, speed, and tension are all adjusted here. A few millimeters off can ruin a whole batch downstream.
The sheet is gradually thinned through a gauntlet of rollers, each one shaving off a little more thickness.
Surface texture here affect how the noodle later holds seasoning and soup.
Once stabilized, this band is ready to be sliced into the noodles you recognize. These blades carve thousands of continuous strands per sheet, creating that springy nest. Gravity helps shape the web into layers that will later compress into bricks. This is the moment the noodle becomes the iconic brick sitting in your cupboard right now. First, the bricks are steamed to cook the starch and set the structure.
temperature and time are tightly controlled, so every brick emerges equally cooked.
Then comes the defining step, deep frying.
Oil drives out water, leaving a porous structure that will later soak up boiling water in your kitchen.
Bricks drain here to hit the target fat level set by the brand specification.
Rapid cooling locks in texture and makes the bricks stable enough to survive shipping. Every ridge and curl is part of how the brick rehydrates and holds flavor. The goal: thousands of nearly interchangeable bricks, regardless of the hour or the shift. From here, bricks are split across several parallel lines to keep up with demand. Between runs, equipment is flushed and sanitized, so food safety keeps pace with speed. On a neighboring line, cups sprint forward to meet their bricks.
Every cup is positioned within tight tolerances, so downstream robots never miss.
Gravity does some work, but the choreography is scripted down to fractions of a second. If it lands crooked, the lid may not seal, so the system constantly corrects for alignment. Precise augers measure out seasoning by weight, not by guesswork.
Even a fraction of a gram off would mean a noticeably weaker or stronger soup.
Oil adds aroma, mouthfeel, and helps carry flavor once hot water hits.
Hundreds of cups are in play at any moment, each running the same script.
Next, lids unwind from reels and are stamped onto cups at high speed.
Time, temperature, and pressure combine to make a seal that survives shipping and storage. This is the first moment the product starts to look like what you see on store shelves. Several lines run at once, multiplying output while sharing common controls.
Humans still step in when the system hesitates, keeping the river of cups moving.
Before these noodles can leave, they have to pass a gauntlet of tests. First, metal detectors scan for any stray fragments from machinery upstream. Anything suspicious, even rarely, is automatically removed from the good flow.
Weight checks confirm that noodles plus seasoning hit target fill levels.
Vision systems look for skewed lids, missing bricks, or anything that breaks the pattern. On top of automation, staff pull random samples for deeper checks.
They actually cook these samples just like you would at home to verify cooking time and texture.
Inside, they're looking for consistent density and no raw, dry pockets hidden in the core.
Seasoning has to dissolve cleanly and spread flavor evenly, not sit in clumps at the bottom.
Even with all the machines, final approval still depends on human taste buds.
Logs show when each batch ran, what it measured, and whether it passed or failed.
Once validation is complete, the focus shifts from quality to getting these cups out into the world.
Even at this stage, someone is still watching for anything the sensors might miss.
Now the product behaves not as individual cups, but as units ready to be packed and shipped.
Hour after hour, day after day, the flow almost never stops.
Cups are grouped into bundles that match how customers see them on the shelf. Shrink wrap hugs these bundles into rigid units that are easier to handle and stack. The film cools quickly, locking the bundle into a single solid block.
Robots handle the repetitive heavy lifting, loading cases, with almost no wasted motion.
Closed cases protect the noodles from impacts and light all the way to the store.
Automated palletizers stack hundreds of kilos of product into perfectly square loads.
Stretch film keeps stacks rigid so they survive long trips without collapsing.
From here, pallets travel to distribution centers and then to the supermarkets you know.
Rows like this represent hundreds of thousands of meals waiting to be bought.
On the shelf, they look simple and cheap, hiding the machinery and planning behind them.
At home, you see only the final brick and a few sachets.
In just a few minutes, all that factory work is reset into soft noodles again.
It feels like a tiny, throwaway meal, but it's backed by a colossal system.
Behind every cup is steel, software, and thousands of decisions you never see. That's how a wheat dust becomes over 1 billion meals,
identical enough that you almost never think about it.